Once you go there, you should be able to see that there's a new addition. So what we'll be going through today, I've added a lot there. So when you check there, you can see what I've added. Okay. So first thing, the first ones already gone through them, so I don't need to go through all those ones. Okay. Now, I think for now we already understand what processes are, right? Do we understand the processes? Do we understand processes? Hello. Hello.
Hello.
Hello. Yeah, I'm asking us that we all understand what processes are.
Yes.
Okay. So now, when what that we needed to do is that there are other processes that goes on in our computer environment. Okay, like in Windows, we use the task manager to check the processes that goes on within your Windows environment. Okay, sorry, the background. Okay, so in the same way, we need to check the process. Okay, so for Windows or operating system processes, we need to get the OS model. So the OS model actually work with the operating system architecture. So everything has been modeled in the OS model. Once we get the OS model, so once we get the OS model, we will be able to get the different processes that goes on within the OS environment. Okay. So the key word is now when I talk about model from our previous class, I believe you will understand the word model, right?
Yes.
Hello. Yeah. Okay, so that is the model that we have. So now within the model, there are different functionalities that goes in there. Okay, so for instance, you could see that we have os.environment. Okay, so os.environment just give us access to our environment variables. Okay, so when you install your application, it creates an environment variable. So if, for instance, we want to check our environment variable, then we need to use the os.environment. Okay, so that gives us access to our environment variables. Okay, so for instance, we have this. Okay, so whatever that I have here, before we can use that one, we know that we need to get our processes working and to get our environment using the OS model. That is going to give us our environment for the OS. So we'll be able to see what goes with the OS environment. Now, okay. So now as you can see here, what that we needed to go through. Now all these processes, the operating system, we have Mac OS, we have Windows, we have Linux. So certain things work for Linux. Okay. So for instance, if I want to get now PWD, now PWD mostly deal with um Linux. So you want to get your current directory for Windows Linux, they use the PWD. So PWD, we cannot use PWD in Windows. Okay. And then we cannot also use the unnamed in the Windows. So these are operating system specific. So all these ones are for Linux. Okay. So by the understanding is the same. Understanding is the same. So what I want you to know that when you pick the environment variable, every environment variable is linked with the key. So you can see it's a dictionary like that value that we will get. Okay, and then each one is linked with a key. Okay, so these are one of the things that I want you to know, so that when we pull that and it comes, you see that each one links with what a key. Okay, so for a try, let's see that we want to try what is here. Now you could see that we have import OS. So once we import our OS, then we can get this one, get PID. Now we want to get the process ID. Okay, and those ones are, like I said, they are for to get that process ID and all those things. So if you want to run this code, all that you needed to do is that the first point is you need to have your input value, like what we said, OS. So that will give us access to our OS architecture. Okay. Now, once you have that, now we can use our OS by calling the dot operator. So the dot operator here help us to get either functions or it could be a function, it could be a model, whatever that you want to have access to within a model, okay, or a package. Okay, that will, the dot operator will help us to be able to call those functionality. It could be a variable, it could be a class. So we use the dot operator to call that. So once you use your dots, then you can get, let's say, get PIID. Now when you run this code, you could see that it gave us the ID, and then this PIID that we are getting here is directly to the process ID. Okay, so the process ID, what is going on there, that's what we're able to get. Now we can also get the directory. Okay, so for instance, what that we went through, then if I want to get my current directory, that is where I am now. So you could see that my current directory here, this is what my current directory here. That is your Python where you are running your Python script, your file, the current directory for that. That's what we are specifying, not any other directory that we are talking. I'm talking about your current directory where you are running your Python scripts. That is what I will mean here. So if I want to get my current directory, I could do os dot get current working directory. Okay, so now this current working directory is going to get that for us. So now you will see that this is my current working directory. As you could see here, this is my current working directory where currently I am. Okay, so now I said that when it comes to the environment variables is when you install your application, it goes through the environment processes. So if we want to check, maybe we want to check the length of environment variable that we have. So we already know what the length function does. Okay, so if I place in os dot env, okay, so env environ, so that is going to give me the access to the length of my environment variable. Okay, so if I run this code here, now you can see that my environment variable that I have there, I have almost 74. Okay, so 74 of them. So now if you want to get only the environment variable that is linked to the home, now you will see here home, this is an argument signifying that the key, because like I said, the environment variable give us what the key and the value. So you already know in dictionary, if you want to access the any value, we use the key. So this is the key that is to save all my environment variable link with what the home key. So now if I come here and I type os dot, let me do os dot env environ. Okay, so this one is going to give me the environment variable, but then when I hit this one like this, you can see that what came here is a key. Let me enlarge it here for you. What came here, now you will see that it's showing the key. I can see here on my environment variable I have a key and then the value for that. Okay, everything the key, so you can see users. Okay, and then you could see that, so these are a dictionary. You could see the carry breaks. So now we want to be specific with the, sorry, my background is making too much. So now we want to be specific with the home key. Okay, so if we want to be specific with the home key, that is going to give us the environment variable that is linked to the home. Okay, so you could see that these are a lot of them. These are our keys and the value. So now you could see that my processor, what I'm having there, and everything that got to do with my environment variable. So you can see here, these are all the files that I have there. Okay, yeah, sorry. So I think now you've seen it, right? So now we want to be specific to a key that we wanted to have. For instance, if I use the key like username, that is going to give me just the username. Okay. So that is what exactly. So now we want to be specific with what the home. Okay. So all that we want to be specific with is the home key. Okay, so it's the home key that we want to focus on. So that is going to give us the home. Okay, so if I check here, now this one is going to give us the home key. So from here, I'll put my open and close square bracket. Then I'll place my key. So what key are we looking at? We are looking at home. So that's going to give us the variable that links to what home. So I'll come here and then type home. And then when I hit enter, now you could see here that it just threw an error and see that a key error home raise. So it tells you that what I just asked for, the home, doesn't exist. Okay, let's check, because if the environment variable exist, that there's no way that the key exists, you won't get this error, key error. You can see that it's just through key error. So let's go to here. Now you can see that these are all the keys that I have. This one key, these are the keys. So you can see that I have all the keys here, the user, then I have the user's key. So what I have here is what home path. What I can see here is home path. So let me copy home path. You can see that I have home path. So home path as a key. So that give me the user kin, and you can see that all the things there. So let's see that. Okay, and then here give us the drive. So home drive give us all the things on our drive C. So let's see like home path. So let's close here and come down there. Sorry. So now I'll change this one to home path and run. Now you will see that it just gave us the one that is linked to the home path, like what we just saw, that links to the home path. Okay, so if we run all these ones here, now all these ones are going to give us a lot of information. Okay, and this goes to do with the user. Okay, so now I have here Windows. So you can see that all the information that are here, you can see them. Then I have path. You see the path here is the key and linked with all these variables. You see that. So the path here is having a lot of value. So it's having like a list. So now let's look at path. So if I copy path here and then replace home path just with this. Let's close here and then change here to path. Now you can see here, I have a lot of them. So that's going to give me all the directories. So like you can see here, I have a lot of them. So you can see all whatever that I've installed, that link with my everything is showing here. So depending on the environment variable that has been captured on your operating system, that's going to give you all the access to those files, as you can see here. So I have all this information here. You could see everything here. Okay. So these are the basic understanding that I want you to get when it comes to the environment variable. So you need to look at whatever that is coming here from the environment is coming as a dictionary. And to access a dictionary value, we use for the key to access that. So for instance, if I have test K125, so when we test this code, what do you think we will receive? We receive an error because this key does not exist. Okay, this key does not exist. So when we try that, definitely we are going to receive an error here because we don't have the key test testing 1 2 3. We don't have that key testing 1 2 3. So definitely when we try, we are going to receive an error. So if I come here, like the same thing that we received, so testing, sorry, testing 1 2 3. So once we run this one, you could see that we have key error because this key does not exist. The same way when we did the home. On my machine, I don't know your machine if you have a environment for key code that work, but if you don't, it was go through an error for you, like the way I have. So now we could assign a new value to a key. Let's say anytime you want to register a key, you give the key name, then you register a value to the key, to the environment, and that will link to that. But let's try this. So if I want to add this one, what will happen is that everything that we need to know about the value that environment variable accept, environment variable does not accept an integer. So you see that you raise an error here, type error, and it's string expected, not integer. So it tells you that the environment variable, the value will always be string, not what integer. So if you assign an integer as a value to your environment variable, it's going to throw an error. So the only way for us to do this is to add this one to it. Okay, so if now I change here to, let's say, a string, by adding a string here, now this will see that now I've added it. You can see that it did not throw any error. If I want to access that, I can use the key, just the key, and you can see that I have this 42. So 42 has been created as the environment variable. Okay, it has been created as the environment variable. Let's see. Let me go to my computer. Let's see that we want to check for my computer here. This PC. Let's check the environment variable and go to more, and then inside more we can check for our property. So if I'm going to check for property, that is going to give me access to. So let's go to and then go to environment variable. Now this is the path. This is the path that I just checked. Okay, so this is the variable, this is the key, this is the key, and then this is the value. Okay, so you can see that variable and the value. So if you want to check your environment variable, so that is going to link to this. So once you check this, it's going to give you access to that. Okay, so that is basic understanding here. So if I pick path, then that is going to give me all the value which is here. So you can see here, path should give us Python scripts, all that whatever that you have here, and together with these ones. Okay, and the OneDrive is a key, and the OneDrive should also give us that. Okay, so basically, this is how. So these are system variables. So inside the system variables, we have all whatever that you see here. Okay, so you can see the OS. You can see OS as a key, and then when you check OS, that's going to give us the window. So I'm is the window empty. So that is going to give us that, and you can check the processor. So these are the keys. If you check username, username is going to give you the system. Okay, so these are all the keys that you can use. So you can see here the variable side, what you see here are the keys. Okay, so now that you've gotten the basic understanding of what we are doing, let's continue. So from here, we'll be able to get that, okay? You'll be able to get that aspect, okay? So if I want to get this information, you can see now here we have our 42, meaning what we've added it to a variable. And so we can also delete everything. So I can delete my key from a dictionary. You know, if you want to delete everything from a dictionary, so you are not deleting all the environment variable. You are deleting what the key. That's going to delete the key and the value associated with. So if for instance here I want to delete, so all that I needed to do is to bring the keyword that is delayed. If so, this is going to delete my key and the value. So if now I want to check again, that should tell me that this one does not what exist. So that will show an error for me because I've deleted it. That's not what exists. Okay. So that is what I want you to do. If for instance I type in let's say path, that exists. Now see that here links us to our path. And this path contains all the Python stuff, what we've installed. So now if I check here, you can still see that I have Python Windows 10 variable like we installed. Okay, with the script here, you can see here. So that links to the path of the environment. Okay, so these are how you can access your environment variable depending on exactly what you wanted to have. Okay, so we can delete them, and then once you delete them or once a key does not exist, it will throw key error. Okay, so if you want to access them that the key does not exist, it will throw what key error. Okay, so I believe this is Hello,
Hello.
hello. Yeah, and is that clear?
Yes, please.
Okay. So that is the understanding of how to get your processes and then get all those things working out. Now let's move on to the next point. Okay, so now we've gotten the basic understanding of how to get all our things, how to get them. So now accessing the operating system utilities and then going through all of them. Okay. Now we can also decide to this one we are dealing with the interpreter directly. So you will see that we are now dealing with the interpreter directly. So with the script that I gave you, you could see that we have if I want to access other or third party applications and stuff that does not have a direct link with the maybe the OS architecture, we can also use a function called sub-process. So sub-process model can be used, okay, to be able to, and the sub-process may have other functionality that we can use from the sub-process like the pop open, okay, which can help us to open a external path or that or whatever. So we use the pop open class as you can see here to be able to get that thing work. So that these are the start process, which we will go to details to understand the search process. But the search process, as I said, the sub process also we depend on the OS specific. So if I'm using Linux base or I'm using the Mac OS or Windows, there are certain things that will not work in Max. For instance, S. Last time I told you that S simply means what? L simply means hello. Hello. Hello.
Hello.
Yeah, can you hear me? Yeah, can you hear me?
Hello.
Yeah, I said L. Yeah, can you hear me?
Yes, please.
Okay, I'm seeing that L simply means what? Do you remember? So L simply means
Alex,
list.
listen. Okay.
Yeah, directly. So this one, this LS here, is for Mac and then Linux. Okay, so if you are using Linux and Mac, you use LS. But then when you come to Windows, we will use LS. So that should be there. Okay, that should be there. I'm clear. So right now, if I come here and I type LS, now you will see that it will throw an error say that LS is not what defined. But if I say that is the directory, it will tell me that it's a built-in what function there. Okay, so that is one thing that you need to know that Windows and then Mac has a different way. So within this context, whatever you do, some may not work for Windows and some may not work for uh, what you call Mac or Linux, depending on the platform. So these are script command that I want you to know. So some commands cannot work for that. Okay. So now, if we want to get use of sub processes where we can interact with external program. So basically, that's what sub process does. So sub process helps us to interact with external program. So they want to interact with the external program, then we can use the sub process to be able to do that. So first thing is you need to import the sub process model into your application. Okay, so what we do is that we import the sub process model into our application. So once that is done, the next point is that you can then use the sub process in your device. You realize that sub process is long, so we can shortcut it as maybe sub and say that import sub process as sub, which we've done that already. So I'm not here to teach you this already. We've covered that aspect. Okay, so now when we have this one, now we can get some functionalities within the sub process model like core. Okay, so the core here can list all the with the core, and then we have a list inside the core. It takes a list argument. So now you can have a list argument here, but you see that this one will not work for the sub process is long. We can just shortcut it as sub. Okay, and I said that using the function sub.core and takes argument a list argument. So sub.core takes what a list what argument. Okay, so that is by default. So when you have here, you have your sub.core here. It takes what a list argument. Okay, so the list argument here. So when you place in a list argument like ls, now we know that ls simply means what? List directory. Okay, but then it worked for Mac and Linux. Okay, so Mac and Linux can use this. So when you want to deal with Windows, that should change to CMD. On Windows, that should say to CMD. That can help us to interact with our command prompt. So CMD, then we have our C, then del. Okay, so this is for Windows only. You can also use this command on Mac or Linux to not work. So this actually is going to list what your current directory, because you already know there. When I do there, it's going to list what the directory. So it's going to list your current directory, the content that you have in your current directory. That's what it's going to do. So for instance, if I run this code, now you could see here that it just listed what my current directory, what I have there. So you could see that I have this one file a.txt, file b.txt, and ls, which I've created them there. So if you go here to our directory, let me go to the directory here. Let's go to the folder. Now you could see that this is the directory that we are in. Okay, and you can create it yourself and link that to your directory. So if I come to all files, then that shows the content what I have here. Okay, now you could see here we have the B. Okay, so the B for by that is going to list only the files that we have without listing any external information. So if I eliminate this one, let's say we eliminate this part and run the same code. At this point, you could see that it has now given us a lot of information. So now show us our directory. This is our directory where we are. And then the file, the time that we created the files, it shows us everything. Then the file size, everything. Okay, but then are we interested in that? No. So maybe we are not interested. We only think that we want to see our fast. Okay, so if that is the case, and that you need to bring this B, so that is going to list only the fast in bytes. So now you can see that if you run this code, that is going to list only the far, because that's what we are interested in. So you're going to list only the far for us. Okay, so now here you could see that when it, after listing everything, it printed everything on a console. You can see that it printed everything on the console. So on console, it printed all the output on console. So if I don't want this one to be printed on a console, we can decide to print it to a different file. Okay, for a different file. So when we are using the sub process, we are dealing with the operating system. We have what we call, we have this, the standard STD, which is called STD, simply means standard. It means standard. Okay, so STD means standard. So when you have a process like STD output, which means that standard output, like the way you have print. Okay, so this is standard output. Okay, that is the STD. You can have STD in, which also means that what standard inputs. Okay, and then output, sorry. Do you get it? So that's what it means. So now, instead of we printed everything on a console, because we know that when we run this code, it will print everything on the console, we decided to write everything to a standard output. So std output, then we open a new file. So now you can see that open here and write. So now we can write the content that is coming here to a file like this file. Okay, for now we already know what this one does. So I think you are not new to that, right? Are we new?
No.
Hello. Yeah, we are not new to that. We know what open does and stuff. So now I can just have this line, but what does is, instead of printing everything to the console, I just decide to use the standard output and then open a new file here and then write all the content to that. So that's what this one means. So if I come here and write this, what it means is that it's going to write everything to a file. So if the file does not exist, it will create it. If it exists, it will update it. Okay. So now you can see that you want to discard the current editor content and reload the file. I say yes, because I've already created that. It's there. So now you can see that it just added a new file. Okay, just added a new file from the one that we just printed here, and then it cleared the old one that was there. I hope you get it. So this is the lstst file that I just opened for us to see the content. So instead of we printed everything here, we can decide to do that in the file. So that is the sub process. It helps us to interact with what external what file. Okay, so the same way that I have this thing, I can also decide to write a script just to print everything from the file. So for here, we already know what this one does. Okay, so I can write a for loop. So for line in open this, so open this, I know that it contains a list of names. Okay, so that will come here, open it, and then I can print individual, okay, within my for loop. So once I run this code, it's going to print everything for me. So you can see all the files that I have here will be printed out. I hope it's clear.
Yes, please. Yeah.
Okay. So that is the sub process. That is what the sub process actually does. Okay. So with most of the information that you see here, now you could actually use the OS to do a lot of far. Now you know that every sub process now in Windows now the processes that goes on like PS mean that process. But in Windows, we use the task manager. When you go to a task manager, you can see all your process. If I right click on this and then check my task manager here, that give me all the process that is going on. But in Mac and OS, that is PS, which is the processes that is going on. So when you check that one, that is different. Okay, but the core, as you can see here, the core function actually is something that we use to interact with what external file or Windows. But what it does is very quick for us to interact with. Okay, so you can write a Python script like this, a Python script, and import your sub processes in there, and now you can interact with any kind of processes, any kind of files and stuff that you have there. Now, if you have a process that is going on and then you want to stop, for instance, if I want to cut a process, maybe I'm creating a process and I want to stop the process, you can either use Control and C to stop it in and stuff control price Z, control price Z also to stop. So it depends on the OS specific. Windows can use control C or Mac can use control C to stop the process. I hope it's clear. Now to open a file. So for instance, if I have a document, I'm creating the document file content here, and then you want to open it, you can use a tool like os.startfile. So os.startfile will actually open the file like the way we have a file like file b.txt. So that is going to do the opening the file. Okay, you can open a file content for us. Okay, and then you'll be able to see what you have in there. And like I said, sometimes if you don't have the file there and you want to open it, of course, if it doesn't expect some nice information to come out, it can throw an error for you. Okay, so you can throw an error for you. So these are some of the things that I really want you to take note of. Okay, so let's see that if now the start process here, like what I just showed you here, is going to open a file for us. Now we can also literally do the same thing by using pop. Now this is a class. So this is a class called popen. So popen is a class. So anytime you see a capital a function or a model starting with a capital like this, it tells you that it's a class. So inside the model, the sub process, we have a class called popen, and with that one, it can help us to manage our processes efficiently. So instead of maybe using the start file and all those things, efficient way to do that, you can use the popen, which can help us to do that efficiently. Okay, But one thing that I want you to know is that if I'm going to use ls, then you know that ls is purposely for what? Mark. So you can only change what you have here to ls, and then you replace it with what? The cmd stuff. But then the other things here remain the same. Now you will see here, see share assigned true, because now we are going to deal with all these processes work directly to the interpreter. Okay, so we are going to see that the share equals to true. That will allow us to be able to continue the process. Okay, but in red term, it's not good because when you do that, it allows injection of truth. So if this thing is there, it's true, the operating system will not what? Try to verify anything, because now you've already stated that this is true. It allows everything to go through. Okay, so we always need to take note of that. Okay, when we want to actually do that, so we have to be mindful to resist from using the share equals to true. But for the purpose of what we are doing, we can do that because we are learning it. But when it comes to the rare cases where you are writing a system or writing an application, you try to avoid that. Okay. So now if I'm going to use pipe and all these things work for Mac OS. So we know that if we are using ls, we are going to deal directly with the Mac OS. Okay. So let's see that we are now dealing with Windows. So I want us to really focus on Windows. Okay. So in Windows, we can still use the class, the POP, to access what? System std in, then std out. I think we already know what std in and std out means, right? Hello.
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 Yeah. Yeah. Can you hear me?
Yes, I can.
Okay. So I'm seeing that for now we already know what an STD in, STD out means, right?
Yeah.
Okay. So we will focus directly to that. So this is standard input and standard what? Output. So for now, the same code that we have here, instead of us using the ls, we know that ls deal with the Linux. We can just replace that with what? cmd cdel this, and this one is going to do the same thing like what we actually did first. Okay, so now if I try this code here, which we have the pop and so now here, instead of this place, I'm going to replace my cmd and stuff there. So I'll just replace that. Now I need to see the pop class. Okay, so if I come here and then I type here sub, which I've already imported, dot pop, that pop, that is the pop class. So if you check this one, then you can see that it just threw this one to me. So now you can see that we have here subprocess.pop. That actually give us that we have the access to use the standard input and then standard what? Output, which means that here everything is open for us. So for us to continue on our applications. So from already code that we've done, we already know how to use this. Okay, so I'll just clear all these parts. Okay, and then come here and then replace my pop. So which is P capital O P E N, which actually got to do with this. Oh, sorry, I didn't close it. Now here, you could see that at this point, I'm able to list all this one out. Now we are using the pop. Okay, so whatever that information that I have here, you can see that here everything came TST, then the far, then the list, then the new far. So, but this is more efficient than the using the core. Okay, you can use the core all right, but then when you want to have more efficient way in managing your file content, we can actually use what the pop to do the same thing, but then this one is more efficient. Okay, you have, because of course you know that this is a class and the other one is a function, and we know what the difference between a class and a function, right, from our previous class, do we? Hello.
Hello.
Yeah, I hope you've heard the question. I'm
Please
saying,
repeat.
yeah, I'm saying that now the pop, that the P open, okay, and the core, they all do the same thing. They all help to manage the resources, okay, sub processes, okay, or external files, external content, okay. But I'm saying that one is more efficient. Okay, now pop is more efficient compared to core because the pop is actually coming from a class. Okay, a class, and you know some of the properties or functionality of a class, right? Ordinary with ordinary function. Do you get it? We may have a functions within a class. Okay, but then when you have a class, you have a function, you can't have a class within a function. Okay, so it tells you that pop is more superior and it can manage um a standard or a resources efficiently than using the core. Okay, so what that we just did, I can use replace the core here. It will give you the same information that the P open will give you. So if I change here to core, sorry, if I change here to core, if I change here to core, it's going to give me the same information, the same thing. Okay, so you can see that we have the same thing. Okay, but this is more efficient. If you can see, this is more efficient. So that is one thing that I want you to take notes. Either you use, but then when you use pop, it's more efficient than to use this. Okay, I hope it's clear now.
Yes. Please, I'm lost on what makes it more efficient. You did say that something about like it has the functionalities of a class, but how does it make it more efficient? Like
Now,
having the
the
functionalities of a class.
if 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 we call this, let's say, let me change this one to pop. You already know that if I want to get more information from you, let's just place this one. Now, now you can see here, you can see here, this is the class called pop, okay, and then it has a different argument. So now you can see here, standard input, we can take in inputs. Okay, here you can take in, these are the functions, you can take the inputs, then pick of outputs here. You see what you can also use it for standard error. So you see that here, if maybe whatever that you are doing here, you can do that universal new lines. You can, it has a lot of functionalities. That is for what I wanted to talk about. Okay, so now if you see here, these are standardized outputs. So you can say STD in, STD out. These are specific for executing program. So if we change here, if we have inputs here, standard input file, which is also okay. So if these are all the functionality, you can use it for encoding. So you can do the encoding, or if you are already you know what encoding, we have encoding and encoding. I think we did that, okay. And these are on Mac, and all those things are already in. Like I said, Mac is used for Mac, so we can't use on Mac, use Mac for Windows. So all these ones are already in there that you can use them in one process. Okay, so
Oh,
you see that we know that. Hello.
hello. Yeah. Okay. Continue. Please continue.
Okay, so we can kill the terminal here. The terminal like a process. If a process is going on and you want to kill it, you use the kill here and kill the terminal. That's the process, or to, like, another way to terminate the process. Okay, so these are different ways that you can choose that. Okay, because it's a class. So once it's a class, you can even get classes for that. Okay, that's why I'm saying that is more efficient than using the normal, just using the core.
So the sub dot
How
p open is a class.
it's a class,
Oh,
and that's why I'm saying
oh,
that anytime you see any word start with a capital, it's a class. I think when we were doing the naming, I told you, or you forgotten,
oh no,
that I
I
said
haven't
that
forgotten.
start with a small letter. A function naming start with what, small letter. A class
Uh,
naming start with what, a capital letter. So you see that P what P. So that should tell you that we are dealing with what, a class, not a function. Let's say that we have sub. Now, when we come here, when we move up there, you can see here, you can see here, you will see here is what, a class. Can you see here? A class P, and it has a built-in what, object. Okay, and these are all the arguments that you can pick. So you can pick all these kind of arguments. We see a lot that you do. Okay, now let's look at the let's look at the core. Let me say that help and core for sub.core. Now you can see here that function core is a model subclass. How you can see?
Yes. What
Okay. So you see where we are here at the top here, we are dealing with the POP. So you can see that the PO pin, these are all the information for the PO pin. Okay.
please, it
Now this
seems
is for
please, your the screen is stuck again. Nothing is your cursor isn't even moving.
yeah, can you see?
Yeah, I see.
You can see now.
Yes.
Okay. So this is where yeah, can you see?
Yeah, I see.
You can see now.
Yes.
Okay. So this is what I want you to take note. So now I was explaining with the core. Okay. So let's say I have the core here. Sorry, you are placing this. So this is what I was explaining the core. Now you can see here, this is what a function core, if you can see. And then he has an argument. So you can see that argument that he have, the time will be in the Q argument. So this is what exactly that this one, you can see that it's very limited with the kind of thing that you can do because this is just a function. Oh, do you get it?
Yes.
Yeah, so that's why I'm saying that you can also use the core to interact with a sub processes, okay, for external application. But then if you want more control, a well organized way to manage your external application or interactive, then you should use the POP, which is a class, okay, which actually has more functionalities that you can use.
All right.
Okay, so that's what we have here. Okay, so you can see, but certain things are like what I just said here, the shell through and all those pipeline. Anytime you pick through, it allows for code injection. So code injection means that maybe a hacker want to attack you, they inject code into the system just for it. That anytime you see this, it allow smooth operation without analyzing anything. So maybe for learning sake, it's good to say share is true, okay, and pipe. But when it comes to a real time coding where you want to do it, you try to avoid this. And then when you are using the pop, it's easy to avoid because we have other way that you can actually do to be able to run the same script. So now let's look at examples of where what we could do, okay, with this, which actually we went through some of these things. So we did an example here, and then we were able to retrieve the files, what we just did here. So you can see that I use the pop here, and then I got the same information as to what we actually use this one for. So you can see that it just gave me all the information here. I could be able to print everything out here nicely on console. This just print on console. And then if you want to print the file, that should be that you should write to a standard arc file. Okay, like what that we just did. So that is the same thing here. So you see that the files will come in the manner in which you actually want them to be. Like all these codes here, as you can see here, are not meant for Windows. Okay, because these ones, the sub pop open, the ESTs and stuff. These are, and then the pipe, these are for Mac, and then the Linux. Okay, so you might, we should try on Windows to not work. But then if you have a Mac OS or Windows, you can still try all this code. And the explanation that I'm giving you is the same. It's the same thing as to that. So if I want to use this one in Windows, then I will use this the cs output.pipe. So in that case, that is going to give everything that you have here to that side. Okay, so if you run this line of code, that is going to work because now standard output, then sub.pipe. You realize that we were having the pipe there. So the same line of code here. Now instead of here, I will place my another argument. So realize that it has a lot of arguments, and one of them was pipe. So now I could do the sub to get the pipe sub dot the pipe, which is pipe. Okay, so the pipe process in there, that is another way. But then you need to give assign it to what the sub process. So I need to assign it to a variable called the system printout, which is the sub process. So that is standard TLD output. Okay, something like this. Okay, so that is the pipe functionality there. So now you could see that it just truncates all these ones here. Sorry. You could see here that we have all the CMD non-arguments here, and then the other processes, the attributes here, and you can see all these are all the handle that. So you could see that we have a lot of information here, the standard output and all these are all the functionality that comes with the POPs. So you could see all of them there. Okay, that these are the attributes that comes with them. So when you go into that, you could see that all the attributes which are showing there. Of course, for now we've done class, so you understand what attributes are. Okay, so that makes that tells you that when you use that one, it's very powerful to use. So PID and then for the pop size, the standard in, the out, the terminate, all this one, universal new line. So these are lots of them that we can actually get. Okay, so okay, so these are what I want you to actually take note of. So, but then when it comes to these ones are not meant for the Windows. Okay, so on Linux we could do the same thing with the pop. Okay, by using the ls, which will actually do the same thing on Linux. Okay, and then which we can also get information from a file, which we can list the directory and stuff, which actually we went through. So when we want to list every information in a directory, we use the dots. Now, when you use the dots here, It's going to give you everything. So it's the same thing. If I want to import a sub, I'm doing that importing something and I want to import everything. In the same way, you can also use the dots. Normally that it gives you every information that is out there. So that is the dot operator here as an argument. Okay, so if I send in and say that OS dot OS dot list directory, list there, and you want to see whatever that you have in that directory, you get the dot operator that is going to give you everything that you have here. So you will see that all the information that I have in that directory is being listed here. So I have the far, this far, this far, this far, this far, and it's going to use that. That is the dot operator here. Okay, which actually we went through some of them. So for now, this is a little explanation that I will give you, just for you to understand how this process is. So now, I believe you understand how to interact with the OS and the different